Hi, this is Michael King. In this video, we're going to look at bond yields and risk, focusing on the price-yield relationship. In Booth, Cleary, and Rikita, this is section 6.2. So let's remember that you value any asset, including bonds, using the magic formula, where you discount future expected cash flows at some discount rate. When it comes to valuing bonds, the discount rate that we're going to be talking about is going to be the yield to maturity, or YTM. The yield to maturity is going to be the discount rate that we use to find the present value of the coupons and the face value for a bond. And in this formula, it is going to be referred to as KB. Notice that the formula is the present value of coupons, which is the annuity formula, and the present value of the face value, which is the future value present value formula. So the relationship between price and yield for a bond is quite straightforward. Most bonds, which we call bullet bonds, have a fixed rate coupon. When you raise the yield, the price goes down, and when you lower the yield, the price goes up because of discounting. The bonds with a fixed rate coupon, the price and the yield to maturity move in opposite directions. So I like to think of a seesaw where you have price at one end and yield to maturity at the other. As price goes up, yield goes down, and as yield goes up, price goes down. So let's look at this example of a 2-year bond with a $1,000 face value that pays a 4% coupon semi-annually. What would be the bond price if the yield to maturity is 5%? Okay, so as you can see here, I've calculated this in Excel. The bond has 2 years to maturity with 2 periods per year, so 4 periods. The coupon is going to be 4% divided by 2 multiplied times 1,000, or $20 for each 6-month period. The discount rate is the yield to maturity of 5% divided by 2. The periodic rate is 2.5%. Applying this discount rate to calculate the present value interest factors, we can see the present value declining as you go further out in maturity. Multiplying this factor times the cash flows, we can see that the price of the bond is going to be $981.19 for a bond with a $1,000 face value. Does that make sense? Notice that the yield to maturity is above the coupon and the price is below, as we saw in the seesaw. Be careful to adjust the discount rate for the number of compounding periods per year, in this case, twice per year. Okay, so if the yield to maturity goes up, the price goes down and a bond will trade at what we call a discount to its face value. Why? Well, it's because the future cash flows that are going to be received are being discounted at a higher rate, namely at the higher yield to maturity. And so they're going to be worth less in today's dollars. So what explains that discount or price below par of $18.81? If the yield to maturity is 5%, what this means is that a new bond from the same issuer would offer a coupon of 5% payable semi-annually. In other words, coupons of $25 every 6 months. But the current bond is only paying a coupon of $20 every 6 months. To encourage someone to buy a 4% coupon bond, you have to compensate them for this lower coupon that they're going to receive by charging them a lower price. How much is the price got to be lower? Well, think about it. You could either hold the bond that pays $25 every 6 months, or you could have the bond which pays $20 every 6 months. So you're going to lose out on $5 of interest. Now there are going to be 4 coupons remaining over the life of this 2-year bond, and that adds up to approximately $20 in difference that has to be made up between the price. Now it won't be exactly $20 because we have to use time value of money. So if we were to take the difference between these two bonds, between the cash flows from a 5% coupon bond and a 4% coupon bond for 2 years payable semi-annually, and discount them at this yield to maturity of 5%, you would see that the present value of those $5 differences is going to add up to $18.81, which is the discount on the price of the bond. What would happen if the yield to maturity is below the coupon rate? Remember the seesaw. Yield to maturity is up, price goes down. Yield to maturity goes down, the price goes up. Why? Well, when the yield to maturity is lower, it means that the future cash flows are being discounted at a lower discount rate. You can see that the price is going to rise up above par, and it's going to be $1,019.27 for this 2-year bond. So let's look at a 2-year bond where it has a 4% coupon and it's discounted at a yield to maturity of 3%. What will be the price? Remember that a yield to maturity of 3% implies that a bond with this characteristics should be paying a coupon of $15 every 6 months, but instead, the outstanding bond pays a coupon of $20 every 6 months. So the buyer of this 4% coupon bond should be willing to pay a higher price to get the higher coupon. As you can see here, we take the bond with the 4% coupon, semi-annual coupons of $20. Here we have a yield to maturity of 3%, which means a periodic rate of 1.5%. You discount the cash flows from this bond, and you find that their present value is going to be $1,019.27. Last question, what happens if the yield to maturity is exactly the same as the coupon rate? In other words, if the coupon is 4% and the yield to maturity is also 4%. We're going to find that the bond is going to trade at 100% of its par value, or at $1,000. We can show this by doing the calculation in Excel, where we calculate the cash flows, the discount factors, and find their present value. Another way of thinking about this, however, is that you're growing your money at 4% and you're discounting it at 4%. So you're going to end up at the face value of par. So what are the other factors that may affect a bond price? Another factor is the maturity at which you're going to receive the final cash flows. The longer or more periods until the bond matures, the more sensitive is the price to changes in the discount rate. When you're looking at discounting and time value money, cash flows that you receive sooner are worth more than similar cash flows that are received later because of interest on interest. So the face value of a bond of $1,000 is going to be the largest cash flow. As you move that face value further out, it has a lower impact on the bond price today because the present value is smaller. So let's take a look. Let's look at two bonds, each pay a 7% coupon semi-annually, but bond A has 5 years to maturity and bond B has 10 years to maturity. Which one is going to be more sensitive to changes in the discount rate? So we can calculate this. What if the yield to maturity decreases from 7% to 6%, for example? On the right, the top is showing you the price at different yields to maturity for the bond with 5-year maturity on the left and the bond with the 10-year maturity on the right. And below, I'm simply showing the change in yield to maturity versus the coupon and the corresponding change in the price relative to par value. So as you can see, bond A, if the yield to maturity decreases from 7 to 6%, its bond price goes up. Yield goes down, price goes up, and it goes up by $42.65. Bond B, however, goes up by $74.39. As you can see, the increase in the price of bond B is greater than the increase for bond A because of the higher maturity. What if the yield to maturity increases from 7 to 8%? With the yield to maturity going up, the price of both bonds is going to go down. Bond A price falls from $1,000 to $959.45, a drop of $40.55. Bond B's price falls from $1,000 to $932, or a drop of $67.95. So again, the longer maturity bond has a greater sensitivity to changes in interest rates. We often talk about this in terms of interest rate risk, where bonds with longer maturities have more interest rate risk.